Okay, welcome to card number 2, and I've got the whole card shown here, and I'll zoom in when I'm ready to do the detail here. But as a start, we go through. We're going to be measuring resistance in series, and series means one after the other. And I've covered up the little resistor symbols here. But on here, you'll see that there's only one path for current flow, and that's a series circuit. I want to make a quick note here. You're going to hear me say this a lot. There's no such thing as a parallel circuit singular, because as soon as you add the second circuit, it becomes circuits. So one of the big misconceptions out there is that there's something called a parallel circuit, when in fact there is not. And that tends to be one of the reasons people get confused, is because the only way for circuits to be in parallel is for there to be more than one of them. So a circuit might have a parallel path in it, but in the final analysis, all circuits are basically series because parallel resistors combine. And there'll be more about that later. But anyway, what I've got here is I've got the board set up, and the notes are resistance is measured in ohms, and the symbol is the omega symbol. And on the meter here, we'll turn it on ohms. All right, so we've got it on ohms. That's the omega symbol. See there, the omega symbol. And I have it on auto range, and that's where I'm going to leave it. If I change it to manual range, it'll say manual on this meter. Sometimes it just says something else. And you'll notice that as long as I'm beeping this, it'll stay on manual. Well, that's not a good thing, because you don't want the meter to do that. You want the meter to be on auto. So if you have an auto ranging meter, you just hold the range button for 2 seconds and it goes back to auto. So there's one of your first meter lessons. So you can go to range, and that's manual, manual, manual. And what that's doing is that's going from, for example, here I'll show you. Okay. That's 400 ohms, 4 kilo ohms, 40 kilo ohms, 400 kilo ohms, 4 mega ohms, 40 mega ohms, and then back to 400. So the meter is cycling around through the ranges. And to go back to auto, you hold the range button for 2 seconds. So I'll move this out of the way, but there we are. We're on ohms, and we're on ohms. In the meter, you can see ohms. And it says auto range at the top, which is where we want to be, and the meter's set to the ohms setting. We're also in the normal nominal volt ohm temperature, capacitor, frequency, and percentage duty cycle are all here, and then amps and milliamps are on this side, so we're going to leave it here. Okay, so there's your first kind of meter doohickey thing. All right, so what you do here is you simply add these up, because they're in series. So it's 100 and 330 is 430, and 390 would make it 730 and 820, and then 820 with 500 would make it 1320. Okay, so in the case of the 500, I goofed, and the resistor set that I told you to buy doesn't have a 500 in it. The other one does. This one doesn't. So we're going to use a 470 here instead. So I'm going to scratch out the 500. I'm going to put in 470 and 470. And that's one of the nice things about these cards, is you can write all over them. You can make calculations. You can do things. I want you guys to practice, 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 practice. Don't just do what I do and then go to the next card. Okay, you need to beat these cards up, use them till, change these, change the experiment, practice, solder some of these together, close them up, open them up, do whatever you want to do, but just practice, okay? Don't get in a hurry to get through these things. Take your time. Couple of quick notes. These are actually half watt, and you can use quarter watt, but these are half watt. They're a little bit bigger, a little bit easier to see. And I think actually in the instructions I used the half watt. Another note here says you cannot use the ohm meter unless all circuits are isolated. I'm going to demonstrate that here in a minute. and it says this is a pain, and it is. So if you're working in the field and you want to be able to ohm things out, you can't do it unless the circuit's isolated. So let me build my fuses here. I want to show you I've already put most of this together, and I'm going to build my fuses. So there's one half of the fuse. Oops. And see, the glue kind of comes loose a little bit. So I'm going to just put this here and make this the second side of the fuse. And there's my fuse. And they do work. And this is at this point just for practice because we're not going to wire this up. We'll do it up later. Going to blow on it there and then make it about that long, and then come back in and do it like this. Whatever you want to do. It's in there, and then you can bend it however you want, make it whatever you want. But there's your fuse. So those are your fuses. Make them as pretty as you want. I really don't personally care. Okay, now what I'm going to do is on the first card, I was kind of frustrated because I was having a hard time putting the resistors down into the stiffer cardboard. I was prepared for it to be something. So I'm going to take my blade and I'm going to kind of just go in there, and I'm going to go ahead and put little slits where I'm going to put my resistors. Alright, and that's just kind of my way of preparing this, and it just makes life easier. Okay, so improvise, do what works. Don't worry about the details, just make it work. Okay, so I'll start with this circuit, and I'm going to build it again, but I'll start with the resistors, and I'm going to zoom in here so that we can see, so that when we solder you can see a little bit better. So I'm going to zoom in, and then I'll move the card, slide this up a little bit. Alright, there we go. Gonna back out a touch. Okay. Alright, so resistors have a color code which you may or may not care about, and you don't have to care about it, but I'll it's in the book. If you own my book, then it's in there, but I'll try to create an insert and stick an insert in here so you can see it. But basically it's the colors of the spectrum. So it starts with black and then ends with white, and each of the colors mean a number. So brown means 1, black means 0, so that's a 10. And brown is 1 again, but what it means is add 1 0, so brown, black, brown is 100. Okay, so I'm going to go ahead and stick that in there, and stick that in there. Okay, so there's 100. And I'll try to put them in order. And then the next one was 330. Well, orange is 3 and brown is 1. So orange, orange, brown is 33 and 10. So that would be 330. Now I'll prove this to you before it's over with. But and by the way, notice the cut marks here, because we're going to have to cut these to make it work. Again, you can solder them back together to play around. And there's a cut mark here for a switch if we were going to turn it on. The next one is 390, so it's going to start with orange, and white is 9, or 9 is white, and then brown is 0. So that would be 39. I'm sorry, brown is 1, so it'd be 39 with 1 0, so that's 390. And I'll prove this to you in a minute. And I'm going to teach you a little bit about the meter as well, because I want you to see how this works. And then I don't have a 500. I've got the 470. So this is going to be 470. Didn't write it there. Okay, so we would subtract 30 from that and we get 1290. So the number we're actually looking for is 1290, or 1.29K. And we'll see how it works out. There's a 5% tolerance. So in this case it's yellow, which is 4, purple, which is 7, so that's 47, and then you add 1 0 because the third band is 1, so you add 1 0, so that's 470. So I'm going to go ahead and I'll stick, come on, get in there, put that in there, come on. It's going to be frustrating a little bit, isn't it? Got to make do, man. I know this works, just not going to work perfectly every time. Okay. So there we go. So this is 470. So we'll stick that in there. Okay, now I'm going to show you something first, because I'll solder these together, solder these in, and I'm going to work from ground back just because it's easier to do. Oops. Okay, so there's that. There's that. See how quickly this goes? This doesn't take a lot of time. It doesn't take a lot of solder. Just a tiny little bit. And that's pretty much it. And you notice how it's nice and smooth, and those are called good wet solders. Those are not cold solders. All right, so if what I do here, bring the ohm meter back in here, I'm going to have to, where can I put this here? I guess I can put it, yeah, there we go. I can put it there. Okay. All right, so what I can do, just to prove a point here, is that because I haven't cut the foil, when I read here to here, it's going to read basically 0. Okay, 0.2, 0.3, very low. It's going to read the same thing here, which is 0. That's 0.3 ohms, which is very, very low. In some cases, that's the best the meter can do. Every meter is slightly different. And we got 0 here, and if I go here, we got 0 here. Okay, so that really doesn't help us. So what I have to do is I have to cut each of these. You will go through blades here because this is kind of tough stuff. I think one of those little knives with the little, break off tips is probably going to be your best bet here. All right, so open these up. So now I have the resistors are now in the circuit. Okay, so you can see they're cut, and there you go. Okay, and they're still fixable. So now the current flow is going to go through here, through here, through here, through and back. Okay, so now we have a series path. All right, well, what I'm looking for is 100 ohms, and let's see what we get. So we're measuring in series. This is resistance in series, so we add them up and we see what we get. All right, so the first one is 90. That's pretty low. That's very low for 100. That's a lot lower than I expected. Let's see what the 330 does. Okay, one of the things that I do here is I make mistakes, and I'm not sure, because it isn't a question of knowing every answer. It's a question of knowing how to find the answer. So I'm not sure. I was getting a weird number here, and it was a number I don't like. So I think it might be because I didn't open the circuit here. All right, now I'm not going to lie to you. I'm not going to cover up mistakes, okay? Because I want you guys to understand that I'm no different than you are. You guys are just as special as you might think I am, and I'm not, really all that special. So I'm going to open that. I'm going to go ahead and open this too, all right? Because, quite frankly, when I looked at this, I'm not really sure where it's going. And what I think I just proved was that by not isolating the circuit, I was getting a number like 90 instead of 100. And unless my meter's broken, which is possible, I suppose, but unlikely, I'll turn the meter off and then turn it back on, and I'll put it here. But now I've opened these paths, and let's see if that changes things here, because I don't want there to be any confusion. I don't want it to be wrong. The number, okay, see now that's better. All right, so let me teach a lesson here. The lesson is, it's really good to kind of have a clue about what you want, and if it isn't there, then you need to ask yourself, why isn't it there? So my first reading was 90, and I knew that wasn't right. And then I came over here and I read something like 238, but what I really wanted to read was 330, and here it's 320. Okay, so that's within, well within the tolerance. Well, now this is going to 390, and I expect this to read about 3.9K, or excuse me, 0.39K, and I get what I'm expecting. And then if I go here, I'm expecting 470, or in this case 0.459K or 459. Okay, because 0.459 is 45% or 46% of 1,000. See the K in there? It's kind of hard to see. Let me do this. I'll do this, and then I'll hit the whole button. And you'll see it's like 0.459K. The K means 1,000, so it's 46% or 0.46 of 1,000, which is 460. Okay, so I'm going to do this again, and let's see if I can do this in my head. Okay, 98 plus 321 is 410? 420. Okay. So 420 plus 380 should be 600 or 700 or 800? 800. That's stupid. And then 800 plus 460 should be 1260. So let's see if we get 1260. And sure enough, we get 1.260, which is 1,260. So let me do this again. And the whole button. I'll teach you this. Make sure you can see this here. 1K is 1,000. And then 26% of 1,000, K is 1,000, right? So 26% or 0.26 of 1,000 is 260. So this is 1,260. Okay, now, so that's how we do that. That's how this works. Now the gold band here is supposed to mean plus or minus 5%. And what you'll notice is the reason that I didn't get the answers I didn't get in the first place is because the circuits weren't isolated. So I'm going to do this. I'm going to close these back up and show you the mistake I made. All right, and it was a mistake. And you're going to make the same mistake, so don't sweat it, man. Don't get too freaked out about it. It's going to happen. You're going to make mistakes, and life goes on. Okay, so let's close that up, and we'll close this up. Okay. So now what I did was I've got this circuit and this circuit attached together. And if I read here, I'm hoping to read 97, 98, but I don't. I read, oops, take it off a hold. Sorry, bring it back in here. See, you always make mistakes. Let's see if I can repeat it. Yeah, see, instead of 97, I got 90. And instead of 320, I get 237. Okay, so the reason that this number is coming up wrong is because those two switches are closed technically, and these circuits are connected together, which is one of the reasons the ohm meter is so miserable as a diagnostic tool. So if we cut these again, this thing's getting dull already. So you're supposed to just play around here. Just play around. Don't. If the answer isn't what you expect, then hey, try again. All right. Well, now everything's isolated. This is isolated here. So if I read this one, I can't get anywhere else. There's no way for it all to connect back together. So I'm reading separately, and instead of 90, which is what I was reading, I now read 97, 98. Big difference. And instead of reading 238 or 239 or whatever, I'm reading 320, which is pretty close to 330. And the same thing is here. Instead of 3 something else, I'm reading 390, and here I'm reading the 460 or whatever. So, and those are within the tolerance. Those are within 5% tolerance. Okay. All right. So what's going to happen is the current would flow, and I don't normally care too much about current flow, and I don't freak out about it, but it's there. So the current flow would come here. If we close this switch, then current would flow here, around here because it's open here, and then around here, and around here, and around here. So current flow would be down here, through the fuse, through the closed switch if it were closed, through the 100, to the 330, through the 390, through the 470, and then back to ground. Okay? The total resistance of 1260 ohms is what we actually measured, but we predicted 1290 based upon those numbers, but the percentage was actually off a little bit, so we're 30 ohms short. Now, in the next cards, we're using these same numbers, so we should be able to see the same numbers and do the calculations for amperage and stuff, okay? So that's the basic concept of resistance in series.